launched the first Android phone, the T-Mobile G1. It was with a simple but bold idea: to build a mobile platform that was free and open to everyone. And today, that idea is thriving. Our partners have launched tens of thousands of smartphones used by billions of people all around the world. And through this journey, we've seen Android become more than just a smartphone operating system, powering new categories of computing, including wearables, TV, auto, AR, VR, IoT. And this brings me to the new version of Android we're working on, Android P. Android P is an important first step towards this vision of AI at the core of the operating system. In fact, AI underpins the first of 3 themes in this release, which are intelligence, simplicity, and digital well-being. So starting with intelligence, we believe smartphones should be smarter. They should learn from you, and they should adapt to you. Technologies such as on-device machine learning can learn your usage patterns and automatically anticipate your next action, saving you time. And because it runs on-device, the data is kept private to your phone. So let's take a look at some examples of how we're applying these technologies to Android to build a smarter operating system. In pretty much every survey of smartphone users, you'll see battery life as the top concern. And I don't know about you, but this is my version of Maslow's hierarchy of needs. And we've all been there. You know, your battery's been OK, but then you have one of those outlier days where it's draining faster than normal, leaving you to run to the charger. With Android P, we partnered with DeepMind to work on a new feature we call Adaptive Battery. It's designed to give you a more consistent battery experience. Adaptive Battery uses on-device machine learning to figure out which apps you'll use in the next few hours and which you won't use until later, if at all, today. And then with this understanding, the operating system adapts to your usage patterns so that it spends battery only on the apps and services that you care about. And the results are really promising. We're seeing a 30% reduction in CPU wake-ups for apps in general. And this, combined with other performance improvements, including running background processes on the small CPU cores, is resulting in an increase in battery for many users. It's pretty cool. Another example of how the OS is adapting to the user is auto brightness. Now, most modern smartphones will automatically adjust the brightness given the current lighting conditions. But it's a one-size-fits-all. They don't take into account your personal preferences and environment. So often what happens is you then need to manually adjust the brightness slider, resulting in the screen later becoming too bright or too dim. With Android P, we're introducing a new on-device machine learning feature we call Adaptive Brightness. Adaptive Brightness learns how you like to set the brightness slider, given the ambient lighting, and then does it for you in a power-efficient way. So you'll literally see the brightness slider move as the phone adapts to your preferences. And it's extremely effective. In fact, we're seeing almost half of our test users now make fewer manual brightness adjustments compared to any previous version of Android. We're also making the UI more intelligent. Last year, we introduced the concept of predicted apps, a feature that places the next apps the OS anticipates you need on the path you'd normally follow to launch that app. And it's very effective, with an almost 60% prediction rate. With Android P, we're going beyond simply predicting the next app to launch to predicting the next action you want to take. We call this feature App Actions. So let's take a look at how it works. At the top of the launcher, you can see 2 actions. One to call my sister Fiona, and another to start a workout on Strava for my evening run. So what's happening here is that the actions are being predicted based on my usage patterns. The phone is adapting to me and trying to help me get to my next task more quickly. As another example, if I connect my headphones, Android will surface an action to resume the album I was listening to. To support app actions, developers just need to add an actions.xml file to their app. And then actions surface not just in the launcher, but in Smart Text Selection, the Play Store, Google Search, and the Assistant. Take Google Search. We're experimenting with different ways to surface actions for apps you've installed and use a lot. For example, I'm a big Fandango user, so when I search for the new Avengers movie, Infinity War, I get, in addition to regular suggestions, I get an action to the Fandango app to buy tickets. Pretty cool. Actions are a simple but powerful idea for providing deep links into the app given your context. But even more powerful is bringing part of the app UI to the user right there and then. We call this feature Slices. Slices are a new API for developers to define interactive snippets of their app UI that can be surfaced in different places in the OS. In Android P, we're laying the groundwork by showing slices first in search. So let's take a look. Let's say I'm out and about, and I need to get a ride to work. If I type Lyft into the Google Search app, I now see a slice from the Lyft app installed on my phone. Lyft is using the Slice API's rich array of UI templates to render a slice of their app in the context of search. And then Lyft is able to give me the price for my trip to work, and the slice is interactive, so I can order the ride directly from it. Pretty nice. So today, I'm really excited to announce MLKit, a new set of APIs available through Firebase. With MLKit, you get on-device APIs to text recognition, face detection, image labeling, and a lot more. And MLKit also supports the ability to tap into Google's cloud-based ML technologies. Architecturally, you can think of MLKit as providing ready-to-use models built on TensorFlow Lite and optimized for mobile. And best of all, MLKit is cross-platform, so it runs on both Android and iOS. we're working with an early set of partners on MLKit and with some really great results. For example, the popular calorie counting app, Lose It, is using our text recognition model to scan nutritional information, and MLKit's custom model APIs to automatically classify 200 different foods through the camera. You'll hear more about MLKit at the developer keynote later today. So we're excited about making your smartphone more intelligent, but it's also important to us that the technology fades to the back. One of our key goals over the last few years has been to evolve Android's UI to be simpler and more approachable, both for the current set of users and the next billion Android users. With Android P, we put a special emphasis on simplicity by addressing many pain points where we thought, and you told us, the experience was more complicated than it ought to be. And you'll find these improvements on any device that adopts Google's version of the Android UI, such as Google Pixel and Android One devices. So let me walk you through